Okay, for assignment 5, first thing you needed to do was just get the R code for Lab 4A, highlight it, and run. You can see that it's just running everything. I've done everything at once there. If you look up at the top of this, you can see the summary for the variable area, and down here the mean and so on. Anyway, if there's the mean and the standard deviation and all that, and if we go back to the first graph, you can see that for area for the population that has a little bit of skew. It's not perfectly symmetric. There's some drop off to the right here, and the average somewhere in here. So we ran the next thing, which what the code did was it said, here's just take one sample from area of size 50. Let's get the mean of that. And then it went down and said, for sample mean 50, let's do that same thing 5,000 times. So we take a sample of area of size 50, do it 5,000 times, and then we make a histogram of those sample means. And what you can see is, here was the population with some skew. Now, your sample means have a bell curve, and it goes from about 1,300 to maybe 17 something. Remember, the population went from somewhere in the, 500 or less up to over 3,000 anyway. So this is much narrower. The next one, that's just changing the width of the intervals on that one. And then back. And then the last one, put the histogram for sample means of size 10, 50, and 100. And this is just the central limit theorem here, that the average stays about the same. In fact, all of these are the same average as the population, but as we take larger samples, the distribution of the sample mean, the sampling distribution of the sample mean, becomes more and more bell-shaped and narrow. Remember, the standard error is sigma divided by the square root of n. Of course, if you don't have sigma, you would do s divided by the square root of n. But the point remains that as n gets larger, goes in this case from 10 to 50 to 100, the center stays the same, mu x bar is equal to mu, and the standard error becomes narrower. Sigma x bar equals sigma divided by the square root of n. Just another demonstration of the central limit theorem. Okay, I did a couple of other things here. One of them, and it won't show up on R on this screen because I'm using a computer. The computer I have right now to use the recording equipment is kind of small screen. But anyway, if I save it as a PDF, sorry about that. My first one here is the area. You can see it goes from down here all the way up to here, and it's skewed. This is just putting everything on one graph, and then here are the histograms with 10, 50, and 100. So the population and all of the sampling distributions have the same center or close to it, while the population has the widest spread, and the spread gets smaller and smaller as n gets larger. Okay, I went ahead and did a couple of other things. That's the one that wouldn't do very well. First of all, I'll show you here, this is just, now I did a box plot. This isn't part of the lab, but you can see here it is. There's the whole population. It has some outliers. If I change the range to 3, that'll show me that we have extreme values as well. And then what I did was, we'll see if this will come up here. I'm going to make this as large as I can here. There we go, it all comes up. This is just the same thing but with box plots. The population has some outliers, and then as you move the sample size up, the center stays about the same. You can see the median there, but the spread becomes much smaller, and you can see by the time you get to n equal to 100, If there's an outlier, it's not very many of them. And then if I change the range to 3 on all of these, now we're going 3 IQRs on either side. Spread this back out. And you can see now with 3 IQRs, by the time you get to n equal 50 and n equal to 100, that you don't have any outliers anymore, that you have, and you can see no skew or anything like that, close enough to a normal distribution. So this is what I mean by n sufficiently large, the sampling distribution, not the sample, not the population, but the distribution of sample means will be a bell curve.